Welcome to lesson number 3, Proportionality. Our learning outcomes for today are simplification of ratios, equivalence of ratios and proportionality, and solving for unknown quantities using proportionality. Let's take a look at simplification of ratios. Simplification of ratios mean dividing both terms of the ratio by a common number until they can no longer be further simplified. In case of B, we divide both terms by 2. In case of C, 4, D, 100, and E, 7. In case of E, we first divide them by 7 and then by 5. Our answer is 20:1. Try the rest of these as part of your learning engagement. Pause the video now. Let's take a look at what does it mean for ratios to be equivalent. We take two ratios, 12:16 and 24:32. Let us simplify them. We divide first ratio by 4, we get 3:4. We also divide the second ratio by 4, and after simplification we get 3:4. You can see that both the ratios are simplified to the same ratio. This means that 12:16 and 24:32 are equivalent ratios. Equivalent ratios can be equated, which means 12:16 is equal to 24:32, or 12/16 is equal to 24/32. Let's try another example. 700:35 and 3500:70. Let's simplify these. We divide the first ratio by 7. We get 100:5, then by 5. We get 20:1. We divide this second ratio first by 10 and then by 7. We get 50:1. You can see that the simplified forms are not equivalent. Therefore, the two ratios 700:35 and 3500:70 are not equivalent. What is the significance of equivalence of ratios? It leads to proportionality. Two ratios 3:15 and 6:30 when simplified give 1:5 as an answer. This means that 3:15 and 6:30 are equivalent. When written in this form, 3:15 is equal to 6:30 becomes a proportion. 3/15 equals 6/30 is also a proportion. Let's see how proportions can be used in real life. We have a field in which some men are working. We have 1, 2, 3, and 4 men working in the field. These men require food to be able to work. We have 12 packets of food for these men. The ratio between men and food then becomes 4:12. What if 2 more men join the team? We see that they would require 6 more packets of food to suffice. So for a total of 6 men, we would require 18 packets of food. We can see a proportion here. If we take the first instance, we have 4:12, and in the second instance we have 6:18, and both the ratios are equivalent. Let us see what happens when we add 3 more men to the team. We have now a total of 9 men. What if someone asks us how many packets of food would be required? We can replace the question mark with X. We know all these ratios are equivalent since we are talking about the same food and men system. If we equate all the equivalent ratios and choose the one with the unknown quantity, we get the following proportion. 6:18 is equal to 9:x. We can solve this by writing them in fraction form. We can now flip the whole equation. 18/6 is equal to x/9. Simplifying gives us 3 on the left side and x/9 on the right side. Multiplying 9 on the both sides gives us 27 as the value of x. This means that for 9 people, we would require 27 packets of food. When quantities in a system show such a pattern of equivalence of ratios, we say that both the quantities are proportional. In this case, men and food are two quantities that can be termed as proportional. They can also be written in this form: food is proportional to men. This sign is called the sign of proportionality. We shall discuss it later. Let's take another example of a car traveling towards the right. The table shows the rate of change of distance with respect to time. A rate is essentially a ratio between two quantities with different units. Do you see a proportion in the ratio between distance and time at the 3 different instances? Also, find the distance that the car has traveled in 11 seconds. If you see a proportion in the given ratios, then show the proportionality between distance and time by using the proportionality sign. Let's practice equivalence of ratios and proportionality. From the following list, we have to find equivalent ratios. I have found 3. 1:3 is equivalent to 4:12 is equivalent to 7:21. Pause the video and find other equivalent ratios. Next, write 3 equivalent ratios for each of these ratios. Let me do the first. 2:5. If I multiply 2 with both the terms, I get 4:10. With 3, I get 6:15. And with 5, I get 10:25. All these ratios are equivalent. Try the rest of these. Pause the video now. Let us now solve unknown quantities in proportions. 1:4 is equal to 2:k, and k is unknown. 1/4 equals 2/k, or flipping the equation gives us 4/1 equals k/2. Multiplying the equation on both sides by 2 gives us 8 on the left and k on the right. In this case, however, we cannot convert the equations into fractions since we have 3 terms. In this case, we would solve for the value of p by comparison. We can see that 2 corresponds to 16, 5 to p, and 8 to 64. Since both the ratios are equivalent, we can also make them equal by multiplying a certain number to the left-hand side of the equation. In this case, that number is 8. Multiplying all the terms on the left-hand side with 8 gives us 16:40:64. We can see that the first and last terms of both the ratios are equal. So are the last 2 terms. That means that the middle terms must also be equal. In this way, we get the value of b, which is 40. Try the rest of the questions and find the unknown quantities in them. Pause the video now. We have reached the end of our lesson. We have achieved our first 3 objectives. In our next lessons, we would achieve the following objectives. Thanks for watching.